This video is about parallel and perpendicular lines from Unit 3, Part 2. We're going to start with talking about parallel lines. So parallel lines are lines in the same plane that do not intersect. Okay, so parallel lines are going to go on forever and never intersect. So to do that, parallel lines have to have the same slope, but it's important to note that while they have the same slope, they have different y-intercepts. Okay, so parallel lines do not intersect, they have the same slope, and they have different y-intercepts. So in example 1, we're going to write an equation for the line that contains the point 5, 1 and is parallel to y equals 3/5 x minus 4. So our first step is to identify the slope. Okay, so we're in slope-intercept form, y equals mx plus b. So our slope is 3/5, so I can write that. Okay, remember, we're going to have a different y-intercept, so really we can ignore that y-intercept. Okay, so we want to substitute the point and the slope into point-slope form. Well, our point is 5, 1, our slope is 3/5. So step 2, point-slope form, we would have y minus our y value equals our slope times x minus our x value, which is 5. Okay, so now we're in point-slope form. We want to get to slope-intercept form, so we need to solve for y for our third step. So to start solving for y, we need to distribute our 3/5. So y minus 1 equals 3/5x. Okay, if we multiply 3/5 times -5/1, those 5's would cancel out, so we're left with -3. Okay, to finish solving for y, we need to add 1 to both sides to get y equals 3/5 x. Okay, -3 plus 1, -2. And so now we have solved for a line that contains the point 5, 1 and is parallel to our first equation. Okay, so y equals 3/5 x minus 2 is never going to intersect y equals 3/5 x minus 4. Okay, we have another write an equation in slope-intercept form for the line that contains 2, -6 and is parallel to y equals 3x plus 9. Well, our first step is to identify the slope. So our slope is going to be 3. Okay, I want you to pause the video and try to find this on your own. All right, so writing this equation, we're going to start with point-slope form because we know the point and we know the slope. Okay, so we're starting with step 2. We have y. Remember, our equation says y minus y1, so we would have y plus 6 equals our slope times x minus 2. Okay, now we need to solve for y in order to get to slope-intercept form. So we're going to distribute that 3. And when we're distributing, we're going to multiply everything inside those parentheses. So we have y plus 6 equals 3x minus 6. Okay, now we need to continue isolating that y. So we subtract 6 from both sides and get y equals 3x minus 12. And so now we have solved for a line that is parallel to y equals 3x plus 9. Okay, so we have the same slope but a different y-intercept. Talking about perpendicular lines intersect to form right angles. So right angles, remember, form 90 degrees. Okay, so a right angle is represented by a box there. Okay, so the slopes of parallel lines are opposite, so one is positive and one is negative, and they're reciprocals. Okay, so their numerator and denominator are switched. So if we had a over b, okay, if we wanted opposite and reciprocal, well, the next one would have to be negative, and then we would have b over a. So these are opposite reciprocals. So some examples. -2 we can write as -2 over 1. So if the opposite of negative, we would have positive, and then for reciprocal, we would have 1 over 2. 4 over 3 and -3 over 4. The first one's positive, the second one's negative, and then we switch the numerator and the denominator. Right, so 7 we can rewrite as 7 over 1. Right, so if we want to make that opposite, we would have negative, and then we would switch the 1 and 7, so we would have -1 over 7. Okay, so if we want to write an equation for the line that contains a point 0, -2 and is perpendicular to y equals 5x plus 3. Well, let's identify the slope first. So we are in y equals mx plus b form. So our slope is in front of that x there, so our slope is 5. Well, if the slope is 5, we need to find the opposite reciprocal. Okay, so the opposite reciprocal of 5, well, remember we can write 5 as 5 over 1, so then we would have negative for opposite, and then reciprocal would be 1 over 5. Okay, so our slope is going to be -1 over 5. Now we want to substitute into point slope form. So our point is 0, -2, and our slope is -1, 5. So we would have y minus y1. Okay, y1 is -2, so we have y plus 2 equals -1/5. We would have in parentheses x minus 0, and you can just leave that as x. Okay, so to solve for y, all we need to do is subtract 2. So we would end up with y equals -1/5 x minus 2. Okay, so this is in slope-intercept form, and it is the line that is perpendicular to y equals 5x plus 3, and it goes to the point 0, -2. Okay, so I want you to pause the video and try and solve 4 on your own, and then once you think you have the answer, press play. So our first step is to identify the slope of this line that we're finding a line perpendicular to. So if the slope is 3/4, we need to find the opposite reciprocal of 3/4. Well, 3/4 is positive, so we would need a negative, and then we switch the numerator and the denominator. So we're at -4 over 3. Okay, now we need to write our line in point slope form. We have our point here and our slope here. So y minus 8 equals -4 over 3x. Don't forget your parentheses, minus 1. Okay, to solve for y, our first step is going to be distributing that -4/3. So if we distribute that -4/3, we have y minus 8 equals -4 over 3x. A negative times a negative becomes positive, and then 4 over 3. Okay, so now we just want to keep solving for y, so we need to add 8 to both sides. So I would have y equals -4 over 3x. Okay, I want to add 8 to 4/3. So over here to the side, I have 4 over 3 plus, and then I can write 8 as 8 over 1. Okay, when I'm adding, I need to find a common denominator. So my common denominator here would be 3. So I'm going to change this to 4 over 3. And then I'm going to multiply the numerator and the denominator by 3. So I would have 24 over 3. All right, now that I have a common denominator, I can just add the numerator to get 28 and then over 3. So I have plus 28 over 3. Okay, example 5, we want to write the equation of a line parallel to y equals 5. If we think about whole wave x, okay, that tells us that y equals 5 is going to be a horizontal line. Okay, so if I want a line that is parallel to a horizontal line, I just need another horizontal line. Okay, so I could write an equation of y equals and then have any number except for 5. So you could pick -3. You could pick +3. You could pick 0. Okay, you could pick any number other than 5 and it would be correct. Okay, you just need another horizontal line and then it will never intersect. Okay, thinking about the other part of our acronym VEX, if our equation is x equals -3, that is going to give us a vertical line. So in order for a line to be parallel to a vertical line, we just need another vertical line. So we would just pick x equals, and then you can pick any number. My favorite number in high school was 7, so x equals 7. Again, you could pick any number there and it would be correct as long as you have x equals, and it's not -3. Okay, if we want to write an equation of a line perpendicular to y equals 5. Okay, if we have y equals 5, that is a horizontal line. Okay, so if we want a line that is parallel to that, we want a vertical line. Well, how do we represent vertical lines? X equals. So you would have x equals and then any number. Okay, for some reason I keep picking 3. So you could have x equals 3, you could have x equals 10, x equals -7, any number there as long as it is vertical. Okay, here we have the opposite. We want to find a line perpendicular to x equals -3. Well, x equals -3 is going to be a vertical line. So we need to think of an equation for a horizontal line. Well, horizontal lines are y equals, and then again, you can pick any number. Okay, so that is parallel and perpendicular lines.